Leaning Tower of Pisa's foundation issues. Welcome back to Blueprint to Reality, where we dive into the world of engineering marvels and structural wonders. Today, we're taking a closer look at one of the most famous buildings in the world, the Leaning Tower of Pisa, and exploring the foundation issues that caused its iconic tilt. Let's jump into this fascinating case study. The Leaning Tower of Pisa, one of the most iconic structures in the world, has a fascinating history of structural issues, particularly its foundation problems. The tower, located in Pisa, Italy, is famous for its unintended tilt, which has been the subject of much engineering study. Its foundation issues have been both a challenge and a key factor in its allure. Background. The Leaning Tower of Pisa was originally intended to be a freestanding bell tower for the cathedral in Pisa, Italy. Construction began in 1173, and it wasn't completed until 1372. The tilt of the tower became noticeable early in its construction due to an unstable foundation. This tilt was the result of several factors, including the soft ground, an insufficiently deep foundation, and the design itself. Foundation and soil problems. The primary issue leading to the tilt was the soil beneath the tower. The foundation was built on a mixture of clay, sand, and shells, which proved to be unstable under the weight of the tower. The soil couldn't adequately support the structure, leading to uneven settlement. This made the tower lean at an angle from its original vertical position. The foundation itself, only 3 meters deep, was far too shallow for the weight of the tower. While initially, the tilt was minor, it worsened over the centuries as the tower's weight caused the soil to compress unevenly. The progression of the tilt. By the 14th century, the tilt became more noticeable. Over the years, as construction continued, the engineers added more height, but the tilt worsened. By the 19th century, the tilt had reached alarming levels. In 1934, engineers attempted to fix the tilt, but their efforts were unsuccessful. The problem persisted through the 20th century. In 1990, the tower was closed to the public due to safety concerns. At this point, the tilt had reached a precarious 5.5 degrees, and there were fears that the tower could collapse. This prompted a global effort to stabilize and preserve the Leaning Tower of Pisa. Restoration efforts. In the late 1990s and early 2000s, a team of international engineers, led by the Italian government and UNESCO, began an ambitious restoration project. The goal was to stabilize the tower without compromising its historical value. The team used a combination of techniques, including soil extraction. Engineers pumped out some of the soft soil from beneath the higher side of the tower. This reduced the pressure on the foundation and allowed the tower to slowly straighten. Counterweights. A massive counterweight system was installed on the opposite side of the tilt to counteract the force pushing the tower downward. Steel cables. To further stabilize the tower, steel cables were attached to hold it in place during the restoration. Through these methods, the tilt was reduced to a safer 3.99 degrees. The tower was also reinforced to prevent further leaning. The engineering lessons. The case of the Leaning Tower of Pisa offers key lessons in structural engineering and the importance of a foundation. It highlights how soil conditions can significantly impact the stability of a building and how critical it is to ensure that a foundation is both deep and strong enough to support the weight of the structure above. The restoration of the Leaning Tower of Pisa is a remarkable example of how engineering ingenuity can reverse a historical structural problem. By using modern engineering techniques alongside careful preservation practices, the tower has been saved from potential collapse, ensuring that future generations can continue to admire this architectural wonder. And that's a wrap on today's case study. The Leaning Tower of Pisa not only stands as a testament to engineering history, but also as an example of how structural problems can be addressed through innovation and perseverance. Thanks for tuning in to Blueprint to Reality. If you enjoyed this deep dive into engineering, don't forget to like, subscribe, and hit the notification bell so you never miss out on more exciting structural insights. See you in the next video.